All right, let's take a look at the decomposition and combination reactions worksheet. So to start us off, I want to remind you that there are 7 diatomic molecules. That means that all of those, they can't be alone ever. They can be combined with a different element, and so they'll have a different subscript, like a 3 for example, but they can't ever be alone. So if they're ever alone, you have to add a 2. Okay? And it says also the equations that you complete below will not be balanced. That's okay for now. We're learning how to balance those in our next lesson. Number 1, complete the combination reactions. Hint, crisscross charges to form products. So Li has a +1 charge, O has a -2 charge, so we need to crisscross. The product is Li2O. For the next one, it's calcium, which has a +2, and sulfur, which has a -2. So those cancel out. So our product is CaS. For our next one, it says silver always has a +1 charge. It had to tell us that because it's a transition metal. Chlorine is a -1. So our product is AgCl. Decomposition reactions are a little bit different. Break the atoms apart and look for diatomics. So that's all we do. We break them apart. We write no subscripts. We completely ignore them. We only write the letters. And then we check, are either of these in Hofbrinkel, one of those special 7? The N is, so it gets a 2. Okay, next one, we ignore the subscripts. So it's just K plus O, and O is one of the special 7, so it gets a 2. It can't be alone. NaF. Na plus F, break them apart, and F is in Hofbrinkel, so it also gets a 2. Number 3, it's mixing them up. It says identify each as a combination or a decomposition. Well, this first one is one compound with an arrow. That must mean it's breaking down. The next one has a plus side to the left of the arrow, so 2 things are adding and forming one product. So that's a combination. Next one, it's one thing breaking down. And the last one too, it's something breaking down. Alright, so let's do all the breaking down ones first, so our brain kind of stays on one track. Al plus N, just break up the elements, and N is in Hofbrinkel. Okay, let's skip the combination. What must this have been before if, when it broke up, it formed NaCl2, Na plus Cl2? Well, sodium's got a +1, chlorine's got a -1, so it must have started as NaCl. Alright, next one. Cu2O. Break them apart. You're ignoring the subscripts. O is one of the diatomics, so it gets a 2. Next one. What must this have been for this combination reaction for it to form MgO? It's tempting to just write an O, but O is one of the special 7. It can't be alone, so it gets a 2. People often will want to add a 2 there. No, it's not alone. It's with magnesium. So it's fine to not have a 2 there because the charges cancel out. Last question, write out the combination or decomposition reaction that's described. Aluminum combines with, we know aluminum is a solid because it's a metal, and all the metals are a solid on the periodic table except for mercury at room temperature. It combines with chlorine gas. I know chlorine gets a 2 because it's one of the elements in the diatomics list, Hofbrinkel. It says it's a gas, so this is a combination reaction. It even uses the word combines, so we're going to have to crisscross. Al is +3, chlorine is -1, so this becomes AlCl3. Now, what state of matter is it going to be? Let's take a look for clues. Solid, gas, this is a metal and a non-metal. That's ionic. That is a salt. Salts are typically solids at room temperature. And the last one, potassium oxide decomposes. Let's figure out how to write potassium oxide. We're going to crisscross. Again, this is like aluminum chloride. It's a metal and non-metal. So it's ionic and it's a solid because it's a salt. If it decomposes, we split the atoms apart. I think this was already one of the ones above. And check to see if either is in Hofbrinkel. The O is. Now, what state of matter? Potassium's a metal. Metals are always a solid, except for mercury. Oxygen we know is a gas, so that gets a little G. All right, hopefully that helps.